We're talking today with Professor Bob Twiggs, who currently teaches astronautical engineering at Morehead State University in Kentucky. Before Professor Twiggs came to Kentucky, he worked in the Aeronautics and Astronautics Department at Stanford University in California for about 14 years. And that's where I met Professor Twiggs and learned all about the satellites that he had built with his college students there and at his previous job at Weber State in Utah. Professor Twiggs has helped to develop the original concepts for small satellites that can be built by students, including satellites called CubeSats, CubeSats, and the Pocket Cube, and CanSats. While at Stanford, he also partnered with the AeroPac High-Powered Rocket Club in Northern California to organize a yearly launch known as ARLISS, a rocket launch for international student satellites. This launch is held each year in the Black Rock Desert about 100 miles northeast of Reno, Nevada. College students come from all over the world to bring their CanSat payloads. These experiments are about the size of coffee cans, and they bring them to Black Rock so that members of the AeroPac Club can launch them on their rockets. Our student project is a scaled-down version of ARLISS with simpler payloads that can be built by middle and high school students and that fit inside of soda cans. These are the size of the original CanSats. Professor Twiggs is an advisor to our project, and we are delighted to have this opportunity to chat with him today. Professor Twiggs, can you tell us a little bit about your background with student-designed small satellites?
Yes, I actually got started with satellites with the students back in 1982 when I was at Weber State University. I was involved in a electronic technology program, and we had some gentlemen that worked for Morton Thiokol, who's the builder of the solid rockets for the space shuttle, and a gentleman from the FAA came to Weber State and had a meeting with the faculty there and said, hey, we want to build a satellite. Will you get your students together? We'll be advisors and help you do this. And we said, sure. I was always interested in space projects and had followed the space program really from the very beginning. So that's we got a program together and actually built a satellite and got it launched in 1984. It lasted about 2 years. It was launched off the shuttle. And it turned out to be such a good project for the students' learning experience and actually us faculty too, that we decided this was pretty good. And so we embarked on another program and had another satellite that was launched in 1990 on the French Ariane rocket. Following that, I worked at Weber State for a while and then was asked to come to Stanford University. I came there in 1994 and started a small satellite program and worked there for a number of years with the graduate students. And now the satellite program in the universities is a pretty big thing. And I think it's a great opportunity for students to learn things we can't teach them in the classroom.
So can you tell us about some of the things you're working on at Morehead State?
Yeah, I've been at Morehead. This is my fourth year here. And, originally it would just kind of get people together and teach some classes on small satellites. And actually Morehead had started in 2005 on a joint Kentucky program to build a satellite called Kentucky Sat-1. It was finally launched just last year, and as happens, this particular satellite was on a rocket that the fairing didn't open, so it now resides in the South Pacific Ocean. So we really haven't got anything launched yet, but we do right now have a satellite that's sitting on a rocket down at Vandenberg that's supposed to launch a week from today, so it'll be exciting for that. Really a very sophisticated satellite, built in a very short amount of time, really a rush job. We're fortunate to have Garrett Jernigan, an astrophysicist that is from California, working with us on it. That is the principal investigator on the payload. We have a very sophisticated X-ray detector on it, and we're hoping to learn some new science from that X-ray detector. Beyond that, what we've actually worked on and are working really hard on right now is we have an opportunity to work on some smaller satellites, and I'm holding up here for you to see this little satellite. It's actually a CubeSat is about a 4-inch cube, and this little guy here was started out as a 2-inch cube, and we've extended it a little bit. We have a launcher. Here's a model of the launcher. You can see in the pocket cube just slides in a rail here, and when it gets up in space, there's a spring foot in there, and the door opens, and this guy pops out. And we're trying to build this actually as simple as we can. What we want is we actually want to have it to transmit in Morse code, which is not the common thing that you do. We have also some other people working on a satellite, and it's so cheap they've named it a $50 sat. So this is a little satellite. This one we have here, we name these things by the length. If it's a single satellite, we call it a 1P for a 1-length pocket cube, which is 50 millimeters long. This was a 2.5P, and this is a 1.5P. And I can show you here. You can see the solar cells that fit on it. They're little solar cells that we buy from a company in California that were never meant to fly, but us cheapy guys found out that the cells were cheap, so we fly them. This is getting ready. We don't have much time. We have to deliver this satellite to Rome, where our partner over there has a larger satellite that these fit into, and it's going to Russia and be launched on a Russian converted ballistic missile rocket. It's down in the silo, and we kind of kid. Well, they open the door on the silo, they pull the warheads off, and they put our satellites on, and away they go. So, it's really exciting, and the students that are working on this right now are mostly freshmen and sophomores, and they don't have a lot of experience, and so it's a real challenge for them. But when you talk to a student about, hey, do you know that in November your fingerprint's going to be in space? There's this great big grin that comes across their face. So it's really a lot of fun, and I think like the rocket program is the kind of thing that the STEM programs we really need to excite the students, and space to me is one of the things that can excite them.
So can you tell us how ARLISS got started?
Yeah, that was an interesting. I met a guy from San Jose named Tom Roush, and I knew he'd been involved in going out to Black Rock and launching rockets, and at the time he was working on a kind of a personal project to build a much larger rocket to go for a prize. I think it was supposed to fly to 100,000 or 300,000 feet. And one time when we're out to lunch, I got to talking to him about what happens at Black Rock and what the rockets were like out there. And he said, well, they had this one rocket that they'd launch, and it was about 7 feet long and would go up to about 2 miles. And I said, well, is it possible to put a payload in that? And he says, yeah, we could work out something on. I think we could. In the center section, we could put a carrier. It's about 6 inches in diameter and about 11 inches long. And what we can do is use a small explosive charge to blow that out. And it's connected with a tether. And whatever you've got in this carrier will be ejected out of it. And I said, okay, what if we fly something about the size of a Coke can on a little parachute? How long do you think it'll take to get it down? He says, well, probably, depending on the day and the wind, he said probably about 15 minutes. And I said, boy, that's great, because, if we could do that, that's just like going through a regular rocket launch, and this 10 or 15 minutes coming down would be the time that you communicate with a small satellite in low Earth orbit. And so we proceeded with that, and they built the carrier, and we went out, and the first year we probably flew 3 or 4 rockets and a bunch of cans, very simple. And then the Japanese found out about what we were doing and asked if they could come over and participate, because they're not allowed to launch these amateur rockets in Japan. And they came, and the payloads kept getting more and more sophisticated all the time. And then the program was named ARLISS for a rocket launch for international student satellites. And we started this in about 1999, and it's proceeded ever since.
Well, I hope we get to show some of the ARLISS student projects later in our video broadcast. What are some of the types of payloads that the teams have been bringing to ARLISS?
Well, they graduated on from these CanSats, and they wanted a much more of a challenge. And what the Japanese proposed, a professor from the University of Tokyo, that they make an autonomous rover that fit in this carrier, and that it come down by parachute, or they have some sort of device that came down that would return to the launch site. And so they tried several things. They tried, having parachutes that were had parasails on them, and many different kind of things, and finally ended up with a rover that they would put in there. It'd come down and land, eject a parachute, and then it would autonomously go back to a flag near the launch site. And it took them actually 4 years in order to achieve this. So they worked on these projects all year long, and it was a great experience for the students, the Japanese students, because typically previous to that in their programs they had not worked on hardware. It had all been theoretical. So this was good experience for them.
Okay, what's one of the most exciting or interesting small satellite launches that you've personally seen?
Well, to me they've all been exciting, and the thing that's happened with me is I never have and didn't particularly want to go to the actual launch site. I thought it was a lot more fun to actually stay at the university, and we generally get to see these launches on TV. And I think one of the really exciting ones was one that we had while I was at Stanford. We launched a satellite called Opal, and it wasn't a small satellite, a little larger satellite than this, but what they did is that was the first one that I'd ever seen launched on a ballistic missile. That was actually one of the U.S. missiles, and it was almost terrifying to see how fast that thing took off. And then I was really relieved when we got the first pass and we could actually hear it. And the satellite turned out to be quite successful. It did what it was supposed to do, and students got a good education out of it.
So why do you think it's important for students to learn how to build space experiments?
Well, first of all, I think the space is important because that's something that the students are really enthusiastic about. In fact, just today I went through my class and asked them, why are you taking this class that I'm teaching on, introduction to satellites and space systems? And they said, I've always been interested in space. And that was a common answer through all the students. And I think it's really important for them to do these kind of interdisciplinary projects. We're just, space happens to be what we're working on, but the interdisciplinary projects to me is what ties your whole education together. And you really don't get that, until after you graduate and go to work in the space industry and then find out how inexperienced and how dumb you really are. And it takes a while to be able to be productive. Here, the students get some real life experience. Not only do they get to work with industry people, our faculty have got a lot of experience. And the interaction, again, with the faculty is a lot different in the laboratory than it is in the classroom. So I think it's an important part of their education.
So do you have any final words of advice for our teachers and our students that are watching this broadcast?
Well, I would certainly encourage the teachers to look for a program to get involved like this. It doesn't necessarily have to put things into orbit like we do. I think the programs like the ARLISS program, put anything on rockets, balloons, anything else. I kind of say, if I can use a party balloon and get anything higher than the top of the house, I'm in space. And going through this process of building something and then actually flying it, whether it be on a party balloon or on a rocket that goes into space, you go through a process that you can't do when you know, just have experiments in the lab. And it really gets the students excited. We find we have a STEM program and outreach to high schools where we have 9 schools right now that we are providing STEM classes on building satellites. And those high school students are so enthusiastic. They're much more excited about this. They get dual credit for it, but they seem to be much more excited actually than our university freshmen. So because it's something new and different for them.
Well, thank you so much for talking with us today. We really enjoyed seeing your projects and learning about the history of ARLISS and CanSats.
Well, you know, thank you very much for asking me, and I think your program is doing a great service to the students in your area, and I wish you a lot of success going out to Black Rock, and I'll look forward to the results.